90% of what you do in the cloud comes down to these 7 services. And I'm going to break down each of them individually and help you be able to master them. And these services might seem simple at first, but it's a good idea to master the services that you're going to spend 90% of your time in, rather than knowing about a service that you're going to use one time and forget about. And at the end of this video, I'm going to give a big example project so that you can put everything you've learned together on your own. First up is EC2. EC2 is the foundation of the cloud. It is essentially where all of the compute happens, and it's the baseline for all of the other services on there. If you ever use anything else on AWS, you're essentially just using abstracted versions of their existing EC2 platform. So it's really important that you understand how it works and all the intricacies around it, because even if you don't use it directly, when you use other services, you'll end up using EC2 in some way, shape, or form. And it is that baseline service that you should have mastery knowledge on if you're going to use the cloud on a regular basis. So what is it? What does it use for? It's essentially a virtual machine host. You can go on and you can deploy your own EC2 instances, your own virtual machines to the cloud, and you can instantly start using them as pay-as-you-go compute. It allows you to spin up whatever infrastructure you want and immediately have like a whole server rack at your disposal. And so these are the key concepts that you're going to want to learn and understand. When you spin up your first EC2 box, you're going to get a choice of different instance types you want to spin up. And this is really helpful because this allows you to define how much resources and power that compute does have. And whenever you do spin up an EC2 instance, you can also choose its AMI, which is essentially the operating system or the base image that's being used to spin up the machine. And of course, you've got security groups. Security groups sort of act like a firewall to your EC2 instance and determine what can come inbound and outbound in terms of traffic. It's really important that you set this up correctly, because obviously if you don't, you may have security issues on your application. Moving on to some of the slightly more advanced topics, you've got things like auto-scaling groups. This allows you to set up an EC2 and then spin up more versions of that EC2 using horizontal scaling, so that when that EC2 instance becomes over more load and it can't handle any requests anymore, you can then expand the number of EC2 instances, so you split the load up across more instances. And of course, if you're going to have multiple EC2 boxes, you're going to need some way to load balance the requests, and that's where the load balancer comes in. There's a couple of different types of load balancers available to you in AWS. You've got a classic, you've got an application, and you've got a network load balancer. Typically, you're going to want to go for an application or a network load balancer, depending on which level of the OSI model you are operating in. And finally, the last thing I'm going to cover in EC2s is something called an elastic IP. Now, by default, if you spin up an EC2, you should get a public IP address. And this is great because this allows you to access your EC2 instance across the internet. However, you'll notice whenever you turn off and back on your EC2 instance, you get a completely new IP address. And this can be a pain if you're planning on taking down your EC2 instance occasionally, or even if you want to then move your app to a different EC2 instance and then suddenly the IP address is changed again. And that's where elastic IPs come into play. You can create an elastic IP from the AWS console and assign it to a specific EC2 instance. Once you've done that, you can freely turn off and restart your EC2 instance, and that public IP address will be attached on there still, and you'll still be able to access it from the internet. Not only that, but you can also detach it from your EC2 instance and attach it to a completely different one, allowing you to essentially transfer traffic from one instance to the other. And I know that's just like a whole dump of information on the EC2 service, but I've also made a little cheat sheet on here so you can refer back to later. So where would you actually use EC2? Well, as I said at the start, EC2 is essentially used everywhere in AWS. The common use cases include things like developer boxes, custom environments for testing, app hosting, and backend services. Also, if you've got a legacy app somewhere that exists on a server, it's not too difficult to migrate it into AWS, start using EC2, and then start to move and migrate to using some of AWS other native services. Now moving on to S3. And S3 has a fairly simple concept of storing objects. Now, these objects can be pretty much anything from videos and files to random database backups. And essentially, it's mostly used for file storage that can be accessible on the web. S3 works similarly to how your file system might work in your home computer. You can create folders inside a bucket to help keep everything organized. You can upload, you can download, you can delete files. One caveat is that when you create your bucket name must be absolutely unique to your region that you're creating it in. And when you configure a new bucket, you have a couple of options. First of all, you can choose to enable or block public access to the bucket, and you can also enable bucket versioning. Bucket versioning just means that you can keep different versions of an object in the same bucket, which essentially means if you've got, like, say you've got a Word document, you can upload it into there, you can upload it again, and you'll have V2 and V1 of the same document, which can be incredibly handy. You can also set up some lifecycle rules. This will allow you to save some money and cost optimize for objects, for example, that you maybe don't use on a regular basis and you wouldn't mind being on some colder storage, which just means that it's less quick to access. Lastly, we have pre-signed URLs. A pre-signed URL is a secure, time-limited link to download and get access to objects in a necessary bucket, without requiring the user who is accessing it to have AWS credentials of their own. This is incredibly useful if you want to, for example, send a one-off download link for a user to download a file, or granting temporary access to premium content that might be locked behind a paywall. Next up, we have VPC. Now, the VPC service is where most of the networking happens inside of AWS. Think of it like having your own data center network. You can create subnets, you can choose your IP address ranges, and you can control who has access to what. One of the key concepts in a VPC is the subnet, and it essentially allows you to break down your network into smaller sections. And we can do this for both public subnets and private subnets. So for example, if you've got a public web server, you might want that to live in a public subnet, where something like your database might live on a private subnet. And we can use CIDR ranges to determine how many IP addresses are assigned to each section. We also have an internet gateway. Now, this is the element that's going to allow you to have a publicly facing app. It allows your VPC to connect out to the internet. You can also configure route tables to determine where each individual piece of traffic is going to go. For example, you might have publicly internet facing data that will go to your gateway, and then you might have internal traffic going to your own network. This goes hand in hand really with what we talked about in the EC2 section, where we talked about security groups, where security groups will allow us to set up firewalls and allow you to determine what traffic gets through to where. But you can also add network ACLs, which act at the subnet level, which are more strict and allow you to have specific rule-based controls. So with a VPC, you're able to completely control what comes inbound and outbound on your networking in your AWS account. And you can use it to design your own custom networking strategy. For example, by using a VPC, you're able to design some multi-tier structured apps. But most importantly, a VPC is a secure, customizable virtual network in the cloud where you control IPs, routing, and access. Now it's time to talk databases, and in this example, we're going to be talking about RDS, which is the Relational Database Service. Okay, so what is RDS? RDS is a service that replaces the need to install a database onto a web server. RDS will provision the database for you, handle all the OS patching, the database patching. It'll automate backups and provide some high availability options, essentially removing all the overhead of managing a database, and so that you can just focus on the data that actually matters. RDS allows for multi-AZ deployments, meaning that your database can run in multiple availability zones, where one is the primary and one is a standby replica. Data is automatically synchronized between the two, and if one fails, then the other one takes over. This means that if anything goes wrong, you don't suffer from any data loss, and your app is back up and running within 20 to 30 seconds, and you can still use the exact same endpoint. Another concept that's quite commonly discussed in RDS is read replicas. What these are copies of your database for read-only queries, as you can have many replicas. This can be very useful when you have some read-heavy traffic, for example, if you're running some dashboard or analytics or something like that. And it means you can offload some of those queries from your primary DB. This is not to be confused with the AZ deployments, which are there for availability. This is not a failover mechanism. This is just so that you can read and get your data quicker. Another thing RDS provides are backups and snapshots. This is configured by default to have a full daily backup with transaction logs. This means that you can access point-in-time recovery, so you can say, for example, I want the database exactly what it was yesterday at 5 p.m. And inside the AWS console, you can configure these options yourself. Snapshots, on the other hand, are manual backups that are stored until you delete them, which can be incredibly useful if you're going to make a big change and you want to snapshot it and make sure that nothing breaks and you can always restore back to it. Now, RDS does allow you to configure how long you want to retain each of these backups. Just keep in mind that the longer that you do retain it, the more cost you're going to come with it, but the more flexibility you're going to have. Typically, people tend to operate in the 1 to 30 days, but there are extreme cases where it might go longer. Automated backups are a good safety net, whereas think of a snapshot as more like a manual save point for your database that you can go back to at any time. Another thing RDS provides are something called parameter groups. Parameter groups are essentially just configuration settings for your database. Think of things like the max amount of connections or how big your cache might be. You can create these parameter groups and just attach them to your RDS as needed. Some will change how the database operates immediately, and sometimes you'll need a reboot. RDS is a managed relational database service that handles availability, scaling, backups, and configuration. Next, we're going to be talking about Lambda. AWS Lambda is Amazon's serverless compute function. It essentially allows you to run code, run functions without ever configuring servers. You upload some code and Lambda will run it whenever you want it to. You don't need to provision any machines, you don't need to scale them, you don't need to maintain them. And serverless architecture is becoming more and more popular in this day and age, mostly due to the fact of how much money it can save. If you're running in the cloud, you no longer need to be paying for an EC2 instance that's not being used half the time. You only actually have to pay Amazon any money when your code is being run, which is fantastic. You're just saving money. Now, to fully understand the uses of Lambda, it might be worth diving into some event-driven architecture. Now, this is a whole topic in and of itself that could have its own video, but for now, I'd recommend this book. Now, one of the disadvantages of using Lambda or serverless, and is quite often stated as an interview question, is this concept called cold starts. Now, instead of having a server that's just sitting there waiting for requests, we've got this Lambda that's got to start up, do its initial initialization, and then run the code, which can sometimes cause a small delay to your code actually being executed. This becomes less of a problem when you're dealing with lots of events happening all at the same time, because you get some form of provisioned resource to do that. But it can still happen and it will slow you down a little bit, but cold starts are just something that you need to be aware of. It's usually a trade-off that's probably worth making, but it depends on your use case. So Lambda can be incredibly useful and incredibly powerful and give you some incredible cost optimizations, but just remember it can't be run for every long-running tasks. Lambda is a serverless compute service that runs code on demand in response to events, automatically scaling while you only pay for the execution time. Now let's talk about one of the most important services in AWS, IAM. And this controls the security across your entire AWS account. And I'm not gonna lie, it isn't the sexiest of services, but it is the most important to get right. We have two key concepts to start off with. We have users that represent either people or maybe applications, and they have to programmatically log in using a username and password or an access key. For example, you might have one for Dave the developer or for your CI/CD pipeline. Roles are temporary identities with permissions. There are no passwords or permanent credentials associated with the role itself, but it's used by AWS services, users, applications, and cross-account structures. Okay, you've got users and you've got roles, but how do you define what they can actually do? Well, this is where the policies come into play. Policies are JSON documents that just define what can be done. For example, you might have a policy that just says, I can access anything inside of this S3 bucket. And you can attach these to users and roles and groups, and anyone within those can go do those actions. So for example, Dave the developer, if I attach a role that allows him to access this S3 bucket, he can then go and access that S3 bucket. But as soon as I detach it, as long as there is no other policy granting him access, he no longer has permissions to do that. A policy comes in three parts. So you have the effect, so whether you're going to allow this to happen or you're going to deny this happening, a resource, for example, maybe our S3 bucket, and the permissions, so what can be done or what can't be done in some cases. So you might have read an S3 bucket, might have write an S3 bucket, change permissions on an S3 bucket. All of the possible actions that you can take against an S3 bucket can be configured against this IAM policy, allowing you to have fine-grained control of what everyone can and can't do. And wherever possible, you should be following the least privilege principle, which just means give the minimum required permissions to do what they need to do. So instead of giving someone access to all of the S3 service, you might say, hey, you can read this one bucket. And sure, that might not matter right now, but it may save you some huge headaches later on if you always implement this principle. Next, we need to cover the concept of assuming roles. For example, we may have Dave the developer who has access to all of the S3 and all of the Lambdas, but needs to access the database for a specific reason. What we can do is we can allow him to assume the database role, which will give him specific permissions to go into the database and make whatever changes he needs. So what's the point of this? If he could just go do that whenever he wants, how does that actually change anything? Well, first of all, it makes it a lot more auditable. We can then see that Dave changed his permissions to the database management, and we can say, hey Dave, why did you have to go into that database just now? I saw you change your permissions. It's a lot easier to keep a track of what everyone's doing. We can also use roles for various services. For example, when we talked about Lambdas earlier, if the Lambda needs to access something, say, let's go back to our example and say the Lambda needs to go off and get some information from an S3 bucket. We can actually give that Lambda a role to be able to temporarily go off to that S3 bucket and get all the files that it needs. And you'll see that a lot of the different AWS services work this way. We can attach roles to various aspects, giving them permissions to do the things that we want, but only the things that we need them to. Services don't automatically have this permission just to go off and do whatever they want. We have to grant them specifically in IAM. IAM is AWS's security system that controls who can access which resources and what actions they can perform using users, roles, and policies. And the last thing we're going to talk about is Route 53. And this ties everything together, making your application reachable from the internet. And we already talked about public IP addresses, public subnets, and internet gateways, which is actually going to give access from the internet, but we don't really want our users to just be remembering an IP address and typing that into the URL bar every time. So Route 53 is the DNS service, which is the domain name system that translates our example.com into the IP addresses that is actually publicly listed and available. Often people refer it to as like the phone book of the internet. The core concepts that we want to explore here are, first of all, the hosted zones. A hosted zone, think of it like just like a container for all of your DNS entries in a specific area. And we can have public internet accessible ones, and we can also have private hosted zones for our internal services. And inside those hosted zones, we can create records. Now, the most common type of record that you might want is an A record. This essentially just maps a domain to an IP address. It could just map example.com into this IP address. We could also have CNAME records. CNAME records map a domain to another domain. And we can even have different routing policies. So we might have a simple routing system where we have one record talking to one resource, but we can also actually introduce weighted routing where we can say, oh, we're going to send 20% of the traffic to this resource and 80% of it to another. This can be really useful for things like A/B testing or gradual integration of a new deployment. Route 53 can also actually monitor your endpoints. So it can quickly determine whether your service is up or down, and if it's down, it can route traffic elsewhere. So in the real world, what does this actually look like? So let's say a user types into the address bar merge-to-master.com. I might have a public hosted zone for merge-to-master.com, and I might have an alias record inside of that public hosted zone that points back to my AWS load balancer. From there, my AWS load balancer can distribute it to any EC2s or Lambdas that it needs to. And of course, with our health checks, we can actually also introduce blue-green deployments, which essentially means that I'm going to deploy a new version of my app. Say I've got my version of my app version 2, but I only really want 10% of the users to see that right now. This means that I can slowly introduce the change and make sure it's working before I open it up to a much larger group of the audience so that I don't ruin the reputation of the site. Now let's put all of these services together and so we can see how they all interact each other to build a basic web app. So we've got a scenario where our user will visit merge-to-master.com. From there, they can log in, they can view data, and they can upload files. The first thing that happens, of course, is that we have our user entry point. Because I own merge-to-master.com, Route 53 will actually map merge-to-master.com directly to my load balancer using an alias record. From there, we can dive into the API layer. When the user clicks that login button, it receives an HTTP request to the login endpoint. And what are we going to get to handle this login endpoint but AWS Lambda? The API gateway receives the request, triggers the Lambda function, and the Lambda actually runs the code. We might even have other Lambdas that authenticate users, fetch data, and process uploads. Now, of course, as part of our app, we also have a database. And our database, PostgreSQL, is running on RDS. And this is going to live in its own private subnet inside of our VPC, so it's not accessible at all from the internet. But you know what can access it? Our Lambda. And that's because we are giving it the IAM permissions, the IAM roles necessary to go off and interact with it. And all of these things pieced together inside of our VPC. We have our private subnet with our RDS database and our internal services, and we have a public subnet with our gateway and our load balancer. Our Lambda is attached to our VPC and can access those private resources. And we have some EC2s running some of our background long-lived services, and also maybe a DevBox so that I can log on and make changes. You can see that throughout all of these services, we've actually integrated security at each level. We've got Route 53, which is controlling our entry routing. We've got the IAMs, which allows the permissions between the services, the VPC providing the network isolation, and the RDS providing private access only. And we're going to use some of those features that we talked about to make some little tiny enhancements. So for example, we're going to use RDS for multiple AZ with some Route 53 failover routing. We can even scale up the Lambdas and the EC2s using some auto scaling. We might deploy new versions using Route 53 using a blue-green deployment, allowing only 5% of the user base to access the new version. And we're using Lambda specifically to save on some cost optimization so that we only have to run code when users actually submit and upload files. So now that you know all of these services, these are the crucial elements that you'll actually need to master AWS. But to drive it home and so you can continue to practice and learn in your own time, I've got a project for you that you can build at home and you can keep referring back to and learning from. On screen is a little bit of an architectural overview, but in the description as well, there is a absolutely free download so that you can access this project in more depth. Thank you for watching, and if you did find this at all useful, hit like, subscribe, put a comment down below on what more you want to see.